So now we dive into the world of object literals and this concept of encapsulation. Now, encapsulation or encapsulating data and behavior is what object-oriented programming is all about. Now, so far what we've looked at is this procedural programming, where we have these variables and floating functions and some mutable operations happening, and we've kind of learned that these aren't particularly good practices. So this is the first step of where we should be going. From where we first start to learn how to program, we would then move things into objects. Now, in this chapter, we're also going to look at the different kinds of objects, such as classes or constructor functions, as well as object literals that we can also use in JavaScript. Now, this video is a short, nice and simple how-to on object literals. Now, the idea behind an object literal is to encapsulate some of these things that we've got here. Now, we don't want to encapsulate the hot dog itself, but we might want to encapsulate these three pieces here. Our cart, which is essentially our state, and this is what I really like to do in my JavaScript or any programming, is think about my state management first, and then everything else is just helping implement some nice patterns such as immutability and some modern best practices. Now, instead of having this cart as an array, we can change this over to an object literal. Now, instead of having our cart as just an array, we want to introduce more of this concept of object-oriented programming through the means of encapsulating data and behavior into a single object. And that's pretty much what object-oriented programming is all about. With object-oriented programming, our applications typically use collections of objects which they just have the data all bound to them. They know how to perform certain actions, they know how to interact with other objects perhaps, and it kind of brings across this concept of self-containment. There are no variables flying around or floating around in our code base. Everything is bound to or will be bound to this cart object literal. Now, an object literal is one of the most basic kind of objects, which is why we are beginning with the object literal, and we'll move on to understanding things such as prototypes, inheritance, constructor functions, and finally classes, and then we'll dive into some more advanced features with these as well. Now, the interesting thing, because we now have a cart, we're going to add an items property. Now, this property isn't going to be a variable like our const cart equals an array is. It's going to be a property on our object. So essentially, when we move from a variable where we had const cart equals the array, that is known as a variable. When we want to bind a variable to an object, this becomes a property where we give it a name followed by the value. Now, in the last video, we talked about procedural programming. So these are the procedures that we are asking for. We're asking for these add to cart, remove from cart, and then they're kind of happening by themselves down here. Now, any procedures that we do want to happen on an object, in fact, become a method. So let's take this add to cart function, go ahead and just delete the const declaration, and we're going to add it as a method. So here we can actually use the shorthand syntax from JavaScript to create a method. Typically what we would have done in the past is do something like this, where it looks like a property and it then in fact contains a function as the value. In ES 2015 or ES6, this was then shortened or allowed us to shorten this to a shorthand declaration, which I think you can agree is far nicer. And when we move across to classes, it basically looks exactly the same, which is good news for us. Now, one thing about classes and object-oriented programming is that we'll probably have to deal with the this keyword. Now, the this keyword isn't that difficult, and I think people overhype how difficult it potentially may be. The this keyword, or the this variable, is simply that. It's a variable and its value can change. So for instance, where we have cart.push, we can't actually do this anymore because we've got cart.items. Now, because we want to reference the items, we need to reference our this keyword so we can talk to our cart object. We can then use .items, and because the value is an array, we can then get return that array and then start using this .items.push. Now, instead of calling this add to cart, I'm going to go ahead and just call it add. Because it's part of the actual object, we can say cart.add when we want to in fact call it. So I don't know about you, but this feels a little bit nicer. We can just say cart.add, and I kind of jump into a new code base and immediately I can read and kind of understand what is happening here. Whereas our remove from cart or add to cart functions, I need to then investigate where this function has been declared. Have I declared it above? Have we imported it from a library? And so on. There are lots of possibilities with object-oriented programming, and essentially it's all about grouping things together, at least things that make sense. So here let's clean up our remove from cart, and what we'll do is go and add it to our object as well. We're going to call this the remove, and again we'll use that shorthand expression. Now because we are using an object, we need to comma separate all of our values, which means that no semicolons are allowed as well. Again, instead of the cart, we need to use this.items, so I'll do a quick find and replace here. The final change that we need to make is our remove from cart function. This is now cart, and we can say dot. Now, before we actually use this, I'm going to show you another nice thing. Because we are using an object, our IDE can in fact pick up on this. So here we've got our items, we've got remove, and we've also got this add function above. So this is a nice thing about encapsulating data and our behavior in object-oriented programming. Everything is quite predictable and it's in one single place. I don't need to go and look at all these different function declarations, and the way that we manage data is a little bit different, I think you'll agree, from the way that we would manage data in functional programming, where we're then passing data from function to function to then get a particular result. In functional programming, our functions are treated as data, meaning that we can pass them around as values or construct higher order functions, and we also looked at concepts such as currying. Whereas in object-oriented programming, things are more concerned about what they are and contain the relevant data and behavior, such as our cart. We'd expect that there would be some kind of collection where we can manage those cart items. We would expect to be able to add and remove items from the cart. So let's save this out and check it out in the browser. So now what we have are two console logs. We have items with array 1, so that's being added into our object, and we finally have items array 0. Now again, because we are using mutable methods, if we do expand both of these, our object has been updated by Chrome. So our developer tools are actually showing me the updated version of our items. If we were to go ahead and quickly refresh and then expand it, before the second log actually arrives, we can then start to see that item. However, it does update because it's mutable. So we can kind of see it quickly before our second log comes into effect, but you can see that objects in JavaScript are an interesting beast. Now, what I mean by this is JavaScript objects and arrays, which is a specific type of object, are passed by reference, which means that when we start mutating things, you can see how we're already causing unintended debugging or perhaps side effects that if we do introduce a bug at this point, it's going to be quite hard for us to debug it using something like a console log, because our mutable methods are actually giving us something that looks like it's happening, but it's actually not. And when we look at our first array, for example, it comes up empty. So again, taking some inspiration from what we've learned about functional programming and definitely steering clear of this procedural programming paradigm, we want to introduce some good practices with our objects. And in the next couple of videos, as we dive deeper, we're going to be moving across to talking more about immutable data structures. And I think this is a really important and great time in the JavaScript world where we can easily start to incorporate some of these good patterns from other paradigms. It was typical that object-oriented programming would strictly be about mutating, so this would be perfectly acceptable in the past, and it is absolutely acceptable today too. However, we do know that immutability is king, so we're going to promote some of these good practices along the way as well. So that's it for this video. We've gone from our procedural programming approach to our object literals and understanding encapsulation. Now, in the next video, what we're going to learn about is the concept of a factory function. Now, this dives into design patterns a little bit more, but I'm going to show you how we can start to evolve our objects to start solving some of the more complex problems that we might have with building bigger JavaScript applications. So we're starting from the base, the absolute bottom, the root of JavaScript here, and then we're going to slowly get more complex as we proceed. So that's it for this video, and I'll see you in the next lesson.